We will discuss the JK flip-flop. Now here the logical diagram for JK flip-flop. Q is the output, Q bar is the complement of Q, J and K are the inputs, and C here is shown here is a clock pulses. Now there are two types of negative edge triggered and positive edge triggered. Let us take the positive edge triggered. Here for corresponding, the truth table has been shown. The positive edge triggered means that when the clock pulses changes its state from low to high, during this period, during this state only, the Q will change. Remaining time, the Q will not be affected. We'll come to the example afterwards. Now this is therefore only it will affect only when the state of the pulses change from low to high, and that is called the positive triggered. Now later we have given a symbol here in the C, we have given the positive trigger by an arrow upward. Therefore this effect will take place only during this transition of the clock pulses from 0 to 1, that means low to high. Now let us discuss the truth table here. When J equal to 0, K equal to 0, and then when the positive triggered is applied to the clock pulses, positive trigger clock pulse is applied, then no change of output. Output means the Q. No change of Q will take place. Now when J equal to 0, K equal to 1, and whatever the previous value of Q, after the clock pulse positive triggered happens, then the Q will be 0. Now when J equal to 1, K equal to 0, then as the clock pulses, positive triggered clock pulses arrives, and then the Q will change to 1. And in the case of a J equal to 1, K equal to 1, in that case the output Q will be toggled. Means every clock pulses, for each and every clock pulses, positive triggered clock pulses, the output will change from whatever from the previous value. That means if the previous value was 0, with the clock pulse, the value of Q will become 1. If it was previous value was 1, then next will be clock pulse. For clock pulses, it will become 0. Therefore, every clock pulses arrives, that Q will change. That is the meaning of toggle. Now we come to on the basis of the truth table, we can prepare the straight transition diagram. Now straight transition diagram I have shown here in this circle. Inside the circle I have shown here 0. That is the state. That means the Q. State means which state is the state of Q. That it is 0, and another state I have considered, because the Q can take a two state only. Either it will be 0 or it will be 1. Therefore, we have shown here one state is 0 and another state is 1. Now you can see here what are the condition that here I have given here this symbol. It means that the previous state was 0, and after the clock pulses positive, because we are talking about the positive triggered, and there are JK flip-flop, there are negative triggered also. Negative triggered is this one, from high to low. Let us take both the types are available. Let us take the positive triggered only. Therefore, whenever the positive triggered arrived, then the output remains to be 0. Previous also it was 0. After the clock pulses, it remains to be 0. That is the meaning of this And what are the condition it may happen? What are the scenario that it may happen? Previous state was 0, next state is also 0. Therefore, here you can see when j equal to 0, k equal to 0, if you put j equal to 0, assign j equal to 0 and k equal to 0, then if the clock pulses arrives, then there is no change from the truth table. Therefore, state 0 will remain as 0. And if j equal to 0, k equal to 1, then also you can see from the truth table, therefore j equal to 0 and the output will be 0. Therefore, because it was previously it was 0, it will remain as 0. Therefore, these two conditions, this scenario happens. Now you can, if you look at that, we can see that the k, if it is 0 also, it will be 1 also, does not matter. If it is j equal to 0, then this scenario happens. Therefore, we can put, in case of a k, we can put x. That means in x means here that it may be a 0, it may be a 1. Now you can come to the another scenario when the state changes from 0 to 1. You can look at the truth table. If it is j equal to 1, k equal to 0, and with the clock arrival of the clock pulse, I don't want to say again and again that positive triggered, that clock pulse arrival means, because we have taken a positive trigger, therefore arrival of clock pulse means positive triggered only. What I am meaning here, positive triggered only. Therefore, if with the arrival of the clock pulse, when j equal to 0, j equal to 1 and k equal to 0, again I repeat, j equal to 1, j equal to 1, k equal to 0, and the arrival of the clock pulse, the state will change from 0 to 1. Another case is the toggle, because toggle, every clock pulses, with every clock pulse, the state will change. Therefore, previously it was 0, then it will become 1 if j equal to 1, k equal to 1. Therefore, these are the two scenarios. This is the two condition of j and k where the state may change from 0 to 1. Therefore, we can see here that k, again it is a don't care. Therefore, if j equal to 1, this scenario takes place. The state changes from 0 to 1. Now you take this scenario where it was previously 1, and after the clock pulse arrives, it will remain to be 1. And 1 is condition is 0, 0. This is no change state, no change condition. 0, 0, no change of the output. Therefore, 1 will remain, output 1 will remain as 1. And 1, 0, if it was previously 0, it will bring to 1. But because in this case, it was previously the q value is 1, therefore it remains as 1. Therefore, if you combine these two, we can get k. If the k equal to 0, it happens, it is x means it may be a 1, it may be a 0. Now, this scenario, let us take, if it is 1 to 0, these are the two conditions, 1 to 0. You look at that, because it is coming to be 0, therefore 0, 1. If it is 0, 1, the output will be 1, and 1, 1, because previous state was 1, the toggle, that means j equal to 1 and k equal to, it will, with the arrival of the clock pulse, it will change its state from 1 to 0. Therefore, this is all about the state transition diagram. Now we'll prepare an excitation table for JK flip-flop. This excitation table is prepared from the state transition diagram. That is when previous state was 0, next state is 0. This is the scenario. Therefore, we put here j equal to 0, x equal to k equal to x. J equal to 0, k equal to x. What we got it here, and therefore when previous state was 0, next state is 1, and this is the scenario 1x, and when the previous state was 1 and the next state is 0, and this is the case, this is the x1, and therefore and in case of a 1 1, that means this is the case, it is the x0. That means this excitation table has been prepared is from the state transition diagram only. Now if we want to find the characteristic equation for JK flip-flop, we have to plot a K-map. We have to simplify the Qn plus 1 with the help of a K-map. And therefore, we want to express Qn plus 1 as a function of Qn, J and K. Now, here we have plotted the K-map Qn, J, K, and therefore Q n 0 and jk 0. Which one this is qn 0, j and k 0. I told that x indicates both 0 and 1. Therefore, it should be included, x should includes both 0 and 1. Therefore, in this scenario 0, 0, 0. Qn 0, j equal to 0, k equal to 0. Your next state is 0. Therefore, this is the block for the qn plus 1. Therefore, we have put 0. Now, Qn equal to 0, j equal to 0, k equal to 1. That means that is also 0. Now, you come to the next row when previous state was 0, then j equal to 1 and k equal to 0. Which is the block it indicates? Here Qn equal to 0 and j equal to 1, j equal to 1 and k equal to 0. This is the block it indicates. Therefore, in this case, Q1 equal to Qn plus 1 equal to next state is equal to 1. Therefore, we put 1 here. Now, Qn equal to 0, j equal to 1, and k is also equal to 1. Which is the block? This is the here j equal to 1, k equal to 1. Therefore, we have you can see Qn plus 1 is 1. Therefore, we put it here. And in the third row, exactly whatever I explained in the third row also, you can see that when Qn equal to 1 and j equal to 0 and k equal to 1, Qn equal to 1, j equal to 0 and k equal to 1, this is the block and therefore it is 0. In this way, we plot from this excitation table, we prepared the K-map, and then we went for simplifications. This is the group we have made, and this is the group we made. For this group, you can see is a Qn bar into k get eliminated, and therefore j into Qn bar. And for this group, you can say Qn equal to 1, and both it gives k bar. Therefore, this is the characteristic equation for the JK flip-flop.